All right. In the previous video that we had, we were focusing on integers, and we came to learn something interesting. I think one of the most interesting lessons that I came to learn was integer bounds. Let me just repeat it again. It says you can access the minimum and maximum values of each integer type with its min and max properties. I just like this. I really, really did. And we were testing it out and seeing how we can make use of this. This other part here, honestly, I didn't really understand. So right now we're on floating point numbers. So that's what we're going to be focusing on. So first of all, what is a floating point number? I guess simply put, it's a number that floats. Well, maybe not, but let me just check something here. Yeah, cool. It's not a number that floats. What is a floating point number? We learn here that floating point numbers are numbers with a a fractional component. Okay, so all these floating point numbers are permitted rather to have, for example, let's say var profit is equal to 3.1. That's a floating point number. A floating point number, as we came to learn, what can it have? Numbers with a fractorial or fractional. Why am I thinking fractorial? Fractional component. That's what we learn about these numbers. We know any number that has a comma or something, these are the numbers that are permitted to be identified as floating point numbers. Floating point types can represent a much wider range of values than integer types and can store numbers that are much larger or smaller and can be stored in an int. Okay, I think that's typecasting here. We may be able to reverse the number back to an integer. For example, we have 3.1. I guess what I'm learning here is that let's call it whole profit, if there's such a term. I don't know if this is gonna work. Complain or something. All right, cool. So we can reverse them back to integers, but obviously we're able to only do so using typecasting. So then how do we reverse them back without typecasting, if there is such a thing? Or they can be stored in an int. Swift, oh, let's see something here then. So that means I'm able to say var whole profit, no, whole profit, okay, which is an int, is equal to profit. Complain. Please complain. Okay, so it's complaining. It says it cannot convert double. So I guess it's only able to do so when we use typecasting, which is a form of function that transforms a floating point number to an integer. So let's see here. Swift provides two signed floating point number types. A double represents a 64-bit floating point number. Okay, so with the sign that we're talking about here, I guess it's not the sign of positive, negative, or zero. Integers are either signed positive, negative, or zero, or unsigned. Okay, we'll get to that. But then what I'm seeing here is that when we talk about this, two signed floating point numbers. Okay, let me write it down here. Swift provides. I'm trying to type as without doing all those things, because I've noticed that it tends to get louder as I type. So I'm trying to type as smooth as I can. Okay, Swift provides two signed floating point numbers, and those are double and lastly, what is the last one? 32-bit. Oh, sorry, float. So far, what I understand from this, even from C++, is that double, obviously, because of the 32-bit floating point number, it can take more characters. So hence, it's more advisable to use double when performing complex accounting, not complex, well, when dealing with money, you want to use double because it can take all those fractional components and place them nicely there together without cutting any. Or I think we saw it here. Or without hitting the, what is this called? I know the value. I know it. I want to use the right term for it. I really want to use the right term. Okay, let me do this. Var or max value is equal to here's the without overflowing. Yeah, that's the value that I was looking for. It's able to take a lot of characters without overflowing. So that's pretty much what it can do. But then that's the double. But then float can take a lot. But now the question is, how much is 32-bit floating number? What is the maximum? We can check it, actually. We can check it. Let's check it here. I don't know how we're going to do that, but apparently we can check it, as we're able to see here. Min double number. Let's check what it's using. But then it doesn't use UINT like we've seen before. Okay, well, we know UINT. Mean, or let's say max. Okay, so the maximum number that it can take is these many digits. Let's check. Well, we know this. I think we saw this. It doesn't begin with a 2, doesn't end with a 5, but it's many because these are 1, 2, 3, 1, 2, 3. Already, I think we're very close to our millions. 1, 2, 3, probably that's a billion. 1, 2, 3, probably there's a trillion. I don't know, but then it keeps on taking a lot of numbers. I don't know how much that is, but then yeah, it takes a lot of numbers. So now the question that I had obviously is how many what is this? How many digits after the dot, if that makes sense? Or decimal digits, I wanted to say that. How many decimal digits can it take? I think we have an answer here. We're saying double has a precision of at least 15 decimal digits. So, wow, that's quite interesting. Let's say max double as a double. So what we're learning here is that double has a precision of at least 15 decimal digits, whereas the precision of float can be as little as 6 decimal digits. The appropriate floating point type to use depends on the nature and range of values. You need to work with your code. In situations where either type would be appropriate, double is preferred. Okay, so double is preferred over floating point, I guess. That's what we're learning here. Hey, don't you dare. Double is preferred over float. Cool. So I think that's it for floating point values. So yeah, let's see. Next time we're gonna continue with type safety and type inference, and then we're gonna go with it. I think it's quite interesting, this typeface safety and type inference. So, yep, cool.